go ahead and look at 3.7. We're going to look at question 5. And I think this is the most, well, this is actually one of the easier questions. We just have to know how to read the table. Okay, so this one's all about reading the table. Okay, so what we need to do is we need to find the y value. So when we look at f of 1, okay, when I say f of 1 or f of x, this is your x value. And what you get out is the y value. So you plug a number in for x and you get out a y value. Now when we want on question 5, f of 1, okay, that 1, well, that represents your x value. So now we're going to go to our table on question 5 here. And these are our x values. So we're going to look at our table. And we're going to find the one that's 1, because that's going to be f of 1. And when we look at f of 1, what does it translate out into? Well, f of 1, if I plug in 1, I get out what? I get out -5. So that's what they're wanting you to do. Okay, when we look at these, remember it's always f of x, and that's your x value. So whatever number's in here, we look it up on the x side on the table, and we find the corresponding y value. So if I would have said, let's say, f of 2, what would f of 2 be? Okay, f of 2 would be -7. F of -2 would be +1. See, these are your f of x values. So your x goes here, okay? And then these are what you get out. Equals is over here. So you just find the value on the x side, and then look at the corresponding y value. Does that make sense now? Okay, just read the table and find the value coming out. Question 6, what they want you to do is on question 6, they want you to write these as ordered pairs. Okay, so it says, this chart shows the number of meals that are served in a restaurant during each of the past 4 months. And we want to write the information as ordered pairs. And we always say that this is x first, y second. So when we create our ordered pairs now, for question 6, they're going to be ordered pairs, and they don't necessarily have to be a number. When we look at these ordered pairs, they're going to be the month and the meal served, or the number of meals, okay? So our ordered pairs are going to be the month that we're in, and then the number of meals that they served that month. So we're going to start off with January, and then we served 3,500 meals in January. And February is next. That's our x value. And we served 3,557 meals. And then we have March. And in March, we served 3,541 meals. And then finally, April. And in April, we served 3,562 meals. So that's all they were wanting you to do, was write them out as ordered pairs. Okay? And they don't always just have to be numbers. Like on this one, it could be the month, and then the y part is the number. So if I wanted to find, let's say, f of April would be 3,562 meals. Okay? So this x is what you plug in. The y is what you always get out. Functions are not difficult, it's just that it's something new. And just trying to understand what they really want you to do in these questions is the hard part. And then we've got 17 and 18. Okay, now 17, we want to determine if y equals a negative 13 is a function. Now, we can look at this just based upon the equation. And we were able to solve it for y. It's been solved for y, so it is a function, right? Now, we can look at this graphically and also show why this is a function. Because this one's actually really easy to graph. If I was to graph this, what would it look like? Okay, if I was to graph y equals a negative 13, 6, 7, 8, 9, 10, 11, 12, 13. Okay, negative 13 is clear down here, and if I was to look at this as a y line, remember a y line looks like that, right? Okay, so that's what y equals negative 13 would look like as a graph. And why is this graph a function? Well, remember, something's a function when you draw those vertical lines and no line touches that graph at more than one place. So every time I have a vertical line here, it's only going to touch that graph at one spot, right? It doesn't double over on itself. So because of the fact this is a horizontal line here, and we were able to solve it for y, then this is classified as a function. Okay, and it just says, decide whether or not it's a function. And it is. You can tell it's a function algebraically because we solved it for y. And we can also graph that y equals negative 13 and see that it's a horizontal line, and then that passes the vertical line test. Right? Because how do you tell if something's a function? You draw vertical lines, and if any line touches that graph at more than one place, then it is classified as a function. Question 18. Okay, question 18 is kind of like question 5 that we did, where we've got to read a table again. And on question 18, what we're wanting to do is we're wanting to find g of March. Now, normally it's f, but it can be g or any other variable. It could be an h here. It doesn't matter, but whatever's in here, again, that's going to be your x value. And so that goes in, and what's going to come out? Well, if we want g of March, that's our x value. This is your x, and this is your y, what you get out, or g of x. So if I plug in March, how many meals did I serve? Well, looking at our table, I served 3,541 meals. We just plug the value in, and we see what we get out. Do we have any other questions out of 3.7 to look at? Before we move on to our practice final, do we have any other questions out of anything in chapter 3 to look at? Are there any old questions that we're still struggling with? Because we have plenty of time before we move on to our practice final. And we've got time to look at any question that you might have. So just tell me what section it came out of. Okay.
Number 8.
Okay, 3.6, question 8.
Number 17.
Sure, 17 as well.
Well, 16 and 17.
Okay, 16 and 17, sure. Do we have anything else out of 3.6 to look at?
In 3.7.
Sure.
Do question 20.
Oh, 3.7, sure, question 20. We can look at that one. Let's just kind of go through them. So we've got 3.7. Okay, we're going to look at question 20. Do we have any others out of 3.7 to look at? Does that take care of those? Okay, and 3.6, we're going to look at 8, 17, and 16. Do we have any other ones out of 3.6? Oh, sure. We can look at question number 2 as well, out of 3.7. Okay, so any more out of 3.7? We've got plenty of time. We can answer any of these that we need to. Because all we have left to do is cover foiling, which will take about 30 minutes or so, and then we're going to look at questions on our practice final. But chapter 3 in general, I want to make sure that we know how to work all of these out, because I think chapter 3 is one of the more difficult chapters, and you're going to see this again in intermediate. So 3.7, we're looking at questions 2 and 20. 3.6, we've got 8, 16, and 17. Do we have any more out of 3.6 to look at? Anything else? Okay, do we have anything out of 3.5 to look at? You don't have answered. We've got plenty of time to go over those.
Can we do 4? I kind of have it. I just want to know.
Out of 3.5?
Yeah.
Sure, yep. And this is a good review as well. It's really good review because you're going to see some similar type of questions on your final. And just so everyone kind of knows about the final, when you work on that practice final, you'll make your notes up off the practice final. You'll use that to do the take-home final. Okay, that gets you ready for the final that you're going to have next week. So you're going to know exactly what questions will be on the final. If it's on the practice final, it's on the take-home final, and it will be on the final exam. Just different numbers in a different order. So if there's an angle problem on your take-home final and your practice final, there's going to be a very, very similar problem with angles on your final exam. Okay, I know on your final, I want you to do well, and I'm telling you exactly what will be on there. And the take-home final is given basically to help you and force you to study and prepare for that final. Students, again, usually do better on that final exam than any other exam because you know exactly what will be on there. We spent time going over it, and you've got the practice final key and the take-home final to work through to help with your final. Okay, so 3.5, we'll look at question 4. Any others out of 3.5? Anything out of 3.4 to look at? That was finding the equations of lines. Anything else out of that? Anything out of 3.3 to look at? Okay, anything out of 3.2 or 3.1? Okay, well, we'll go ahead and begin then. And we're going to do 3.5. We'll start with that one. And we're going to look at 3.5, question number 4. 3.5 is finding equations of lines. And on this one, they want you to read a table. So let's see if we can't figure out what we're trying to find here. And a lot of these just require us to think about what are we doing. So we got to make sure we know what these words mean, what we're trying to find, and then use the information. So the table lists the average annual cost of tuition and fees at certain two-year colleges for selected years, where year 1 represents 1992, year 3 represents 1994, and so on. We have this equation, and we can use this equation to approximate the data. We need to predict the annual cost in 2007. So we need to figure out what we're starting with and what value of x we're going to be plugging in. So x represents the years. And it says in our table, x equals 1, well, that goes with 1992. X equals 2 would then be 1993. Right? We're adding 1 every time. X equals 3 is then 1994. And we need to figure out the x value that would go with 2007. Okay, so we need to figure out that value. Now, what number are we going to plug in? Well, look at our pattern. We can fill out the pattern all the rest of the way, or we can just figure out the difference and add together. So let's look at what we're starting with. Okay, we're going to start with 1992. And we want to end up with 2007. So let's find our difference. So 2007 minus that 1992, well, what is that difference now? 2007 minus that 1992, well, that's a difference of 15. Okay, so there's 15 years difference. Now, in 1992, where are we going to start with on our x value? We're starting with 1, right? So our difference is 15. If we take that 15 and we add 1 to it, we get what? 16. So that means in year 16, that corresponds with what? With 2007. Is everyone okay with how I got that? Right, I looked at how far the difference was, and then I looked at where I started. So we started at 1. I took that 1 and I added it to the 15-year difference here, and that gave me my 16. So that 16 is our x value. So here's our equation. Y equals now 27x plus 1068. And we're going to use the value of x, that is 16. Right? So that's our number. This is called key data. A lot of times in statistics, you don't use a year, you use a smaller number to represent that year. It just makes it easier for calculations. So 1 is 1992, 2 is 1993, 3 is 1994, and so on. So we found out we want a difference of 15. We add 1 because we started at 1. That gave us 16. Now we can plug in that 16. And now we can find our final answer. And we can find our cost in 2007. So the cost for that community college in 2007 is going to be 27 times your 16 plus your 1068. And it should come out to be $1,500. That's going to be your tuition costs for community college in 2007. Okay, so 2007, it's going to cost you $1,500. Is everyone okay with how I did that? Does everyone see how I got the numbers? And if you take a statistics course, we do a lot with key data. So you do this kind of thing a lot, where you label them differently so they're easy to work with. So 3.6 is what we're going to look at next. And in 3.6, we're looking at graphing these inequalities. And let's just take a moment to remember how to graph these inequalities. When we graph and work with these inequalities, what do we know? Well, they're either going to have a solid line or they're going to have a dotted line. And how do we know which one gets which? Well, that depends upon the inequality symbol. So greater than, less than, those are represented by a dotted line. Greater than or equal to, less than or equal to, remember, those are going to get a solid line. And so we're now going to look at question 8 in 3.6. Okay, and question 8, we just kind of talked about that a moment ago. And it says, so what's the difference between this inequality and this inequality? Well, the difference is going to be that inequality symbol, right? And so all I really want is you to understand that strictly less than, strictly greater than, those are going to get a dotted line. Greater than or equal to, less than or equal to, well, those are going to be represented with a solid line. So all I want you to tell me is that one gets a solid line and one of them gets a dotted line. If you want to write it out in words, you can. If you put these on here, your inequality symbols and the lines, that would be okay too. My thing is I want you to understand what those symbols mean and which one gets a solid line and which one gets the dotted line. And that's the only difference between them. Is when we go to graph them, one gets a solid and one gets a dotted line. Okay, so that's all I was looking for on question 8. Question 16. Okay, on question 16, I want you to kind of look at the graph here and figure out which ones it could be. Now, we can go ahead and use process of elimination. So when I look at this graph, what do I know? When I look at this graph, what are we doing from left to right? We're going down from left to right, aren't we? So what does that mean? That means your slope is going to be negative. So that means the number in front of your x has to be negative. So we can go ahead and eliminate d. Right? Why can I eliminate d? Because d has a slope that is positive 2. And we want a negative 2 for the slope. Is everyone okay with that? Right? Now, what else do we know? Well, when we look at our picture, we have a y-intercept here of 0, 2. So that means that number on the end has to be a positive 2 because we're above 0, right? This is at 2 here. So which ones can we get rid of now? Or which one can we get rid of? B. Why can we get rid of B? Because the number on the end is negative, right? And that would make it down here. And ours is clear up here. Let's see how I use process of elimination. So now I look at my 2 remaining choices. And we've got it down now to either A or C. So when I look at this, let's find 0, 0. Okay, 0, 0 is right here. And this half is shaded. So 0, 0 should be true because it's on the shaded half. So when I plug 0, 0 in, it should make it true. One of these is true. One of these is false. We want the true one because 0, 0 is in the shaded region, which is the true part. So let's take answer choice A and plug in 0, 0. When I do that, then I get 0 is greater than or equal to 2. And is 0 bigger than 2? No. So this one is false. So that one is gone. Now let's double check and make sure that C is true. If I plug in 0, 0 into C, that gives you then 0 is less than or equal to 2. And is 0 smaller than 2? Yes, so that's true. It should be true because 0, 0 is here. So what's your answer going to be? Your answer for that one is C. And so what I did was I used process of elimination with the slope and with the y-intercept to narrow my choices down. And then I looked and I said, okay, where's my 0, 0? 0, 0 is here, and it's in the shaded part, so it better come out to be true. I didn't have to check those two because they were gone, right? We already got rid of them. They're done. So we only had to check it in 2 of them. And all we had to do was find the one that was true, okay, because 0, 0 is in the true part. Okay. Question 17. what is the minimum number of quadrants totally or partly shaded in the graph of y is greater than mx plus b, where m is greater than 0, b is greater than 0. Okay, so let's take this one and let's plug in numbers. All right, so we know some certain things about our equation here, our inequality here. They give us certain conditions, and we're going to make up one that falls into this condition. We're going to graph it, and we're going to see which quadrants it covers. So this is what we're going to start with, is y is greater than mx plus b. And we know that m is greater than 0, and b is greater than 0. So m is greater than 0, b is greater than 0. What do we know about m? M is greater than 0, so let's use m equals 2. Okay? 2 is greater than 0, right? We want to pick numbers that are going to make it true. So we know m equals 2 will work. Why? Because m's got to be greater than 0, and it is. And let's use b equals 3. Why 3? And you could use 2, you could use 12, you could use 10, you could use 1. It doesn't matter as long as b is what? Bigger than 0. So we're going to use 3 for the b and 2 for the m. And now we've got y is greater than 2x plus 3. Now let's graph this inequality. And we're going to count how many quadrants that it lies in and which quadrants. Okay, so how would we graph this one? Well, what does that 3 represent? That represents your y-intercept. And that y-intercept is in 0, 3. What does the 2 represent? Well, that represents your slope. We've got a slope of 2. And we've got a y-intercept of 3. So how do we graph that? Well, we know we're going to have a dotted line, right? Because this tells me right here that this is going to have a dotted line. Then we'll shade it. And then we'll answer our question. So we need a dotted line. And where do we start at? We start at 0, 3. Okay, so that means it's up 3 units. And what about our slope? Slope is m. It's 2 over 1. So we go up 2. And we go over 1. So we start our 0, 3. We go up 2 units. And then we go over 1 unit. Make our new dot. And now we connect them together with a dotted line. Now we need to shade. What do we do to shade? We check a number, an ordered pair. Where do we usually check? If possible, 0, 0. Okay, so let's check 0, 0. So we plug in that 0, 0. Okay, and that gives you then 0 is bigger than 3. Well, is 0 bigger than 3? No, that is false. So that means this half is false. So that means this half up here would be what? True. And where do we shade? We shade the true half. Now, what it wants is it wants us to know and decide which quadrants are going to get shaded. And in case you forgot what the quadrants are and where they're at, let me show you the picture in the textbook that talks about quadrants. And that's in N3.1. So here's your quadrants, and here's how they're labeled. This is way back on page 213. We don't use quadrants a lot, but this is how they're labeled. Quadrant 1, 2, 3, and 4. So they go counterclockwise. So what we want is we want to know which quadrants are going to be shaded. So we pick numbers for M and B, and it says what is the minimum number of quadrants totally or partly shaded by this graph. And which quadrants are they? So when we look at our picture, which quadrants are going to be covered? Here's our quadrants, and here's our graph. Well, it looks like we've got a little bit shaded in quadrant 1, right? We've got quadrant 2 completely shaded, and it looks like we've also got a little bit shaded in quadrant 3. So which one is not shaded at all? Quadrant 4. So on this one, which ones are either partly or completely shaded? Well, they're going to be quadrants 1, 2, and 3. Okay, so quadrants 1, 2, and 3 are either completely or partly shaded. And what we did was we picked numbers, and we used an example, and we shaded it, and we looked at our picture, and we said these quadrants were shaded, 1 or partly, 1, 2, and 3. And so those are the quadrants that are listed out. Quadrant 4 is not shaded at all. Quadrants go counterclockwise. We don't talk about quadrants much at all, but they're just labeled 1, 2, 3, and 4, and they go counterclockwise. So I think that takes care of all of our questions out of Chapter 3. Did anyone have any other questions out of Chapter 3 to look at? Well, I guess we still got to go 2 and 20 on 3.7 though. So we did 3.5 and 3.6. We got 2 questions out of 3.7, which are 2 and 20. We did some of these earlier. Okay, let's go back to 3.7. And we're now going to go ahead and do question 2. And we kind of talked about this last time, about what I wanted. So we have a table of numbers here, of values. And I said we're going to use 2 ordered pairs to make our line. So let's use -2, 1, and 0, 3. And we want to come up with our answer in slope-intercept form. Okay, now, this is a good example of something you're going to see on your exam next week on your final. You won't be given the table, but you're going to be given these 2 points. And we need to find the equation of a line using those 2 points. So this is something that we did way back in 3.4. So how do we find the equation of a line given 2 points? This is a good one to review. It makes you go back and tie everything together. So we've got -2, 1, and we've got 0, 3. And we want to find our answer in slope-intercept form. And again, this is something that you're going to see on your practice final and your take-home final too, and the real one in class next week. You're going to have something like this. You're going to have 2 points, and you're going to have to find that equation. Now, what do? Well, we think about what we have. What do we currently have? 2 points. So when we pull out that flow chart, and you can use that flow chart on your exam next week. I've got a copy here. we'll use to go over. Make sure you bring it next week because it does help out a lot, I think. And we're on the second page. You want to find the equation of a line given 2 points. That's what we've got. And how do we go about doing that? We need to first find our slope. So let's take our 2 points and let's find our slope. Our slope formula is m equals y1 minus y2 over x1 minus x2. Remember that formula. You follow it along, and you can use this on your exam, this flowchart sheet. We label our ordered pair, x1, y1, and the next one, x2, y2. We plug our values in. And so that's going to be, now watch it, make sure y goes on the top. So the last numbers go on top. So that's going to be 1 minus 3 over minus 2 minus 0. 1 minus 3 is a minus 2. Minus 2 minus 0 is still a minus 2. Minus 2 over minus 2, that divides out, and that makes it 1. So my slope is now 1. We need to go ahead and find our equation. And that's our next step, right? Use the point slope formula. Now you can use either point that you want. I'm going to use 0, 3. Why 0, 3? Because it's got the 0 in it. And I think that'll make it a little bit easier. So I'm going to use that 0, 3 with that slope of 1. And we're going to use now our point slope formula. And that is y minus y1 equals m times x minus x1. And that is x1 and y1. And you, again, can use either ordered pair. Use whichever one is easier. I am using the one with the 0 in it because I think it'll be a little bit easier. So we've got our point, we've got our slope. So now we proceed to use our point slope formula. And that's going to equal then 1 times x minus 0. And we distribute that 1 through. 1 times 0 is gone, so that just leaves you with an x. So y minus 3 equals x. We'll add that 3 over. And then what's my final answer in slope-intercept form? Y equals now x plus 3. And that's what they were wanting. So they want you to use those 2 ordered pairs that were provided that I gave you from the table. Apply your slope formula first. Then use your slope with your point slope. And get your answer in that y equals mx plus b form, which is your slope-intercept form. Okay, so that's what they were wanting you to do. This was kind of a review of what we did back in 3, 4, and 5. We've got one more question to look at, and then we'll take a short break. And we'll come back, and we'll start reviewing some for your final next week. So let's look at one question here, question 20. We'll take a break. We'll come back. We'll look at some questions on our practice final, and we'll cover how to use the FOIL method to finish up all the topics and outcomes and objectives that we need to. So we're in 3.7 again, and we're going to look at question 20. Question 20 says, decide whether this is a function or not. How do we decide if something's a function? If I give you an ordered pair or a table like this one, how do we know if something's a function? Well, we look for duplicated x values. All right? And if any of the x values are duplicated, then it's not a function. They can all go to the same number, but what we look at is we look at the domain, and we look at our x values. Remember, the domain is the x values, and our x values are -9, -6, and -15. Are any of those values duplicated? No. So that means this is a function. So question 20 would be a function because each x goes to a specific y value. They can all go to the same number, right? But that's still a function. So question 20 would be a function. Now let me make it not a function. Okay, if I would have added on, let's say, -9 and -12. Okay, if I would have added this on, let's say I added another row here. Let's say I added -9 goes to -12. Would that be a function anymore? No. Why not? Because the 9 would have been duplicated, right? Anytime you have a duplicated x value, it's not a function. So as it is originally, it's a function. If I add on that next row, -9 goes to -12, it would not be a function. So this is a function originally. If you add on another value of -9 to -12, it would not be. So how do we tell if something's a function? We look at the x values. And if the x values are duplicated, it is not a function. So let's now go ahead and take a short break. We'll meet back here at, let's say, 9:30. And then we're going to spend the rest of the class period going over the last topic, foiling, for your final exam, and then some questions on your practice final as well. So meet back here in about 15 minutes.